Thanks very much for coming, everybody. We'll officially start now. So many of you know me. I'm Evan with kimaru.ai. I'd like to introduce Priya. Do you want to do a little
Hi,
self-intro?
I'm Priya Sultan. I absolutely love this community. I love the team here. It's just so vibrant. There's so much information in this room. So I hope you guys get some information from us. And if you have some more information about decision intelligence, that you share it with us as well. So thank you for having me and thank you for joining us.
Yeah, applause is appropriate. Why not? Really? I thought that was very smooth. And Dr. Hareesh, my co-founder and CTO.
Good evening, everyone. I'm Hareesh. I'm CTO of Kimaru AI company. And I also have a small startup in India. It's called Squash. And today, some of those topics will be covered here, which will be connected to decision intelligence through Kimaru. And also maybe we look forward to hearing from you, your feedback, suggestions, support. Thank you.
Thanks, everybody. I think the echo is gone. Those in the back, could you hear us okay? Can you hear Dr. Hareesh okay? Okay. All right. Thanks for checking. So this is a simultaneous in-person and live event. So we're trying to optimize it for people who will see the Zoom recording later. Just want to make sure that the audio and all that stuff is good. So thanks for bearing with us a little bit. All right. So we'll dive right in. Oh, wait, one more person to introduce. Our other co-founder, Sinjin, our CEO. Stand up, take a bow. Nice. Was that a curtsy? Elegant. Okay, thanks, everybody. So kimaru.ai, we are a decision, prediction, and recommendation AI platform. Today's topic is about decision intelligence for social impact. One moment. Hopefully the slides move forward. Okay. This image, I'm sure, is very familiar to everybody. I'm sure you've all been in the situation where you get into meeting after meeting and you can't reach a decision. It goes on, and it's really hard to find stakeholder alignment. But what is the cost of this? Well, it turns out it's really high. Indecision costs the average Fortune 500 company $250 million a year. That's over $680,000 every day per company. So really, that's inexcusable. But that's not just a business problem. It's actually a planetary problem. You can see in the background here, these are the SDGs, 17 SDG goals that have been set, and our progress towards them as of last year. The indicator at the top is pretty important, and it's a little bit of a problem. Only 15% of the targets are on track, and many are actually going in reverse. As UN Secretary General Antonio Guterres said, I hope I got that pronunciation right. Daniel, was it close? No, okay. Instead of leaving no one behind, we're actually at risk of leaving the SDGs themselves behind. So why does this happen? Why can smart people set goals like this and then fail to make progress towards them? Why is it that we get stuck in these indecision sort of bottlenecks and continuous loops where nothing moves forward? Well, it turns out it's actually because we're overwhelmed with too much data. And decision makers are so overwhelmed that they're just struggling to function. About 40% of executive time is spent making decisions, but current business intelligence tools, they fail to give clarity on what exactly to do. So what decision makers need is decision navigation. They need to know exactly what actions lead to desired outcomes. Now, we're all familiar with the type of decision navigation. This is a screenshot of Google Maps. You can see Shibuya to Tokyo Station has been mapped out here. Google Maps processed all of the data that they have, and they recommended this route. And a few hours later, they made an updated prediction and recommendation as congestion increased. The previous route didn't really make sense anymore. It would have taken too long, so they recommended this route. Well, our software, kimaru.ai, does exactly that. With action outcome decision mapping, it gives you recommended routes that you can take to get your desired outcomes using AI predictions and recommendations. Now, sometimes things change and that route may no longer be the best path. So depending on the data, it will update and recommend other paths. This is like A/B testing your decisions. Should we take action A or B? Does this path make more sense or does this path make more sense? What is the probability that you're going to get to your desired outcome? And the way this works is like this. Essentially, we visualize, predict, recommend. So the methodology here is using this action outcome decision mapping. And this is not unique to Kimaru. This is actually the field of decision intelligence. It's a growing field. We'll talk a little bit more about it later. And Priya, you've been studying about it, right? Kept you up all night. Yeah, we think it's really exciting too. So this is essentially the solution to these problems. And the result of utilizing human judgment and AI predictions is much faster time to decision. So this vastly improves productivity. How it works is like this. You map out your desired outcome. You set a quantifiable metric to that outcome, your North Star metric, exactly what it is you want to achieve. You map out the actions you can take and the intermediates, the things that they will affect, and any external factors that will affect them. This creates a training environment for machine learning so that we can build AI predictions and recommendations. So here's an example, specifically for social impact. SDG number 3 is good health and well-being. So the desired outcome here is to reduce patient readmission rates. And some of the actions that you could take would be to personalize patient care, implement training programs, benchmark individual patients versus the overall population. Now that sounds hard to do, but one of the key learnings of decision intelligence is that you don't have to have massive amounts of data. You just have to have data at key points in the decision model to train the algorithms. So in this case, really all we need is healthcare SaaS. Examples might be Optimum 360 or Care Cloud, a good CRM, and maybe external data like the WHO database. And then we can start building these prediction recommendation models at key points. Another example, SDG number 4 is quality education. So the desired outcome here is student performance. That's a quantifiable metric. And you can quantify it using different platforms, test scores, and so on. And the actions you can take to achieve this are implementation of digital learning programs, developing after-school programs, mentoring by students' peers or community, and so on. And the data that you need, again, it's relatively light. We don't need massive amounts of data. We just need very pinpoint data. EduCloud, international student barometer database. This is an external database that you can use to map this out. SDG number 6, which Dr. Hareesh will be talking about in detail in a moment, is clean water and sanitation. And the desired outcomes here are things like the liters per day of clean water that you can generate, the kilograms of day of refuse that you can remove from water systems. And actions you could take, well, you could install Dr. Hareesh's technology, SQUAS. This would allow you to clean waterways at critical points. And this will allow for also the collection and disposal of refuse and then distribution of water to the, let's say, the end users in this system. The data required there is IoT sensor data, water flow data. So you need to take into consideration flooding and aspects like that. And then the geolocation data mapping out proximity to distribution centers. Here's another example. SDG number 7 is affordable and clean energy. The desired outcome would be something like kilowatts per day sent to grid from the solar collection units. This is a personal example. What's visualized here is a smart house. This is kind of modeled after my house. I built a smart house a couple of years ago, and we powered it with solar panels. We have a battery. And every time we can generate enough excess energy to cover our own needs, then we can sell that to the grid. So that supplies more energy to everybody. And what we need is a load balancing system. So weather API, solar grid, sensor data, and really just those two data points is enough to build a decision intelligence model so that we're meeting this goal. Here's another example, SDG number 9, industry innovation and infrastructure. Desired outcome here would be something like kilowatts per hour saved. Actions, you could predict hot and cold days, and then you could stock vending machines with cold and heated drinks, and then heat and cool them only as necessary. Many of you have probably seen on really hot days, all the vending machines in the train stations, they're sold out of water, and then Pocari Sweat and Aquarius and stuff like that. Well, that means that they kind of failed to predict the demand based on the weather. And by simply connecting IoT sensor data to an ERP system and a weather API, you can better predict that. And then you don't necessarily have to be cooling water on cloudy days. You can save a lot of energy that way. SDG number 11 is sustainable cities and communities. Anybody recognize the photo here? Pretty famous. I think some people in the audience probably know what this is. Obviously, we're taking kind of a famous use case here and saying that it's decision intelligence, which it is. But this is not our software's use case, to be clear. The desired outcome here is mode share optimization or modal split. That means essentially sharing modes of transportation. And the actions that you can do are divide your transport areas into high speed, medium, and then like pedestrian areas, track the individual movement, which means you have to have sensors on pedestrians and individual, personal mobility devices, cars, and so on. But once you've tracked all of that, then you can store the data in a data warehouse and optimize the mobility rates depending on the type of transportation. All right, so essentially the unique insight here is that you don't have to process massive amounts of data just to find patterns to get insights from, and then maybe get actions that you can take. You can kind of flip that model around, and you can start with the specific outcomes that you want to achieve, map the actions you can take that would affect that, and then connect machine learning to run predictions and recommendations just at the key points. So your overall data processing load is hundreds of times smaller. That also connects to SDGs because now you're not burning a lot of cloud infrastructure just to power all of the machine learning. So you can be much more efficient with your AI models. All right, so here's our team. We've already introduced ourselves. Just one quick jump over here. I wanted to help you visualize what this actually looks like. So when you build a decision model, it looks like this. Set your desired outcome, actions you can take, external factors that might influence those, and the causal chains in between. Maybe later in the Q&A, if anybody wants to dive into that, we can look at some more of these examples in detail. But essentially, this is what decision intelligence, decision modeling looks like. All right, and a quick shout out. If anybody wants to dive into real detail on this, we're running a workshop course. Our next one's going to be on July 24th. Please sign up. We're going to be holding it at our office in Shibuya, and you can get a deep dive into all of this technology. Okay, enough sort of one-way lecturing. Now we want to get into a conversation. All right, so we'll open it up to the panel. And Priya, do you want to start? Do you have any initial comments?
Oh, I have tons of comments. I'm sort of new to this, but I find it really, really interesting because we're processing so much data on a daily basis, but we don't have a human element there. So now you add human intelligence, and all of a sudden there's ethical decision, there's nuances, there's so many different factors that previously we didn't have, right? So now if we do it correctly, you can make better decisions. But there's obviously challenges in the process, and I think we'll probably discuss those later. But I as I mentioned earlier, I was really excited about this because I think that's always been lost. The humanity behind it, right? The social behind it, the ethics behind it. So Now that we add that element, it suddenly becomes more tangible. It becomes more real, at least from my understanding so far. And again, like, I'm relatively new to this. I've been doing social impact for far longer than I'd like to admit. But, this idea that we can make better decisions in social impact by integrating human intelligence in this data that we have so much of, that's exciting to me.
So a couple of really interesting points there that I want to dive into. One, you highlighted the human component, right? What we want to do here is not like automate the decisions. We don't want the AI making all of the decisions for us. We want this human in the loop synergy. So we're leveraging human experience and judgment and things like regulatory frameworks and existing procedures, right? And then we're kind of giving a hint with the AI, like maybe try this, maybe try that. That I think is it's really essential, and that's what keeps, like you mentioned, the ethical component in this, right? Because we want to ensure that humans have the oversight over the overall system, right? Right. And then I think maybe a second point, you mentioned social impact. What is social impact? We should probably define that.
Well, I mean, I think, look, as I mentioned, I've been doing social impact for over 15 years now. And 15 years ago, what people thought about social impact was, oh, you're just an NGO. And that's not what social impact is, right? Social impact is making a positive impact through business, actually. They're saying that we can use business to make people's lives better. And that focuses on each and every one of those SDGs. And it's really, really critical because economics play a huge role in the world. That's undeniable. But the problems that we had 15 years ago, they've just become so much more because sometimes people, don't necessarily do the right thing or make the right decisions. So hopefully this process can help that. Because I think we all want to live in a better world. We see what's happening around us and it's devastating. So that's what I'll say.
Yeah, and not only is it becoming more and more important to make the right decisions, it's becoming harder and harder because we are getting so overwhelmed with data. To the point where we can't possibly individually process it all and then know what the right actions to take are. So we tend to get just sort of overwhelmed and in many cases kind of give up. That's what leads to decision fatigue, right? I think it's really important to tell personal stories and really, kind of relate it to the audience for a personal level. So you told me before how you got into social impact and how you started your company, which I think is a great story. Would you mind relating that?
About the girl that was here when I came for the first time, or back in India when I first started?
You've got time. You can rewind, tell the whole story.
Okay, I'll try to keep it brief and interesting. So bear with me. I was in banking. That's what I was doing. And I just, I grew up with a mom that worked at UNICEF. I was born in India. Like, the problems that we've seen, you see on a daily basis, but I just felt like I was making no difference in the world. The whole market crashed and I was like, this is an opportunity. So I packed up my stuff and I moved to India. I was just like, forget it. I'm out. And I went there and I worked on a project with a man named Gopi Gopal Krishnan. And the reason I mention that name is because he was so influential in my life in making me understand how economics, data, and humanity can actually change the world. Wonderful man, super intelligent as well. So I moved to India and I started working on a project, a telemedicine project. So what was happening in rural villages, and we're talking just 3 or 4 kilometers outside of major cities. I was working in New Delhi, so that's where I was. And you go out there and people are getting medical care from basically local quacks. They're paying 10 times, 20 times the price and dying essentially. In particular, I remember, I'll try not to get upset about it because it still really angers me. But I sat down with them. I speak Hindi, so I was able to communicate with them sort of in their own language, which is a lot more comfortable, of course. And I sat down with a husband and wife, The husband was very, very quiet in the back. And the woman was sitting with me on the steps of her house, which are made of dung, right? They're living in rural parts of India. So I asked her, like, what happened when you worked with this local quack? And she got such bad information. She was pregnant. She got such bad information that they lost their child, not once, but twice. So the husband was just like a shell of himself. It was the worst story I ever heard. And I was like, no, this has to change. And that for me was really the point where I was like, no, I'm never ever doing anything besides social entrepreneurship and social impact. That is my North Star. I think everyone should have education, water, healthcare. It's so basic and it's so easy to provide. And we understand what the data is, but the human element was taken out. So that's why this excites me, because it could accelerate the process of more people getting care the right way, being able to eat, being able to have proper healthcare. So that's part of the story. I'll stop there for now.
I think it's a really compelling story. Yeah. And I think it's really important to tell the story of what you're doing about it. So maybe you could connect that to how you started your company.
Yeah, absolutely. So after that, I did my master's. I had to know everything. And I was like, okay, I'm going to do a 1-year master's. Ended up joining an organization called the HALT Prize. There was also a leader there named Ahmad Ashkar. And he was just like, you know what, Priya, go find your North Star and go and do that for the rest of your life. And then he taught me about social entrepreneurship and how it really, really works. I did that for 12 years. So, you know, once you find that North Star and you find the thing that really drives you, don't do anything else. And find and surround yourself with people that are aligned with how you feel about it. And look at things like this, which is I didn't sleep because I was like, if we had this, then maybe we could have gotten healthcare faster to these villages, right? So, yeah, I think that's a really important part. Now, what happened was I was going around. HALT Prize is an organization that like has students come up with social enterprises all around the world. We started with like 5 countries. We were at 121. I was moving around all the time. And he said to me, Pri, you want to go to Japan? I said, yeah, okay, let's give it a shot. And I came here and I was speaking at a university. It was Showa Women's University here in Tokyo, actually. And I was just talking, you know, I just kind of do my thing. And afterwards, there was a young lady that came up to me, and maybe you guys know this, maybe you don't. I don't know, but like sort of in Japan, you just follow a certain path, right? And by the time that you're the age of 30, you essentially cannot change your path. You're done. So I spoke at this university, and then people will come up and talk to you afterwards. And it's always, I love working with students because you just see the light turn on in them, right? Which is so fun because you're like, listen, do whatever you want with that light, but okay, at least I got one piece of information to you. So this young lady came up to me. She must have been no older than 19 years old. And she burst into tears. And I was like, I'm not capable of handling this. I don't have the qualifications. So I was like, are you okay? Is everything okay? And she said to me something that I was like, I have to go to Tokyo for the rest of my life, or for at least a period of time. She said, today was the first time that someone told me that I could do what I wanted to do. And I was just like, I literally get goosebumps. And then I was in Tokyo, I was in Osaka, I was having that similar conversation with a lot of young people. And the young people are the ones that are going to deal with the nonsense that we've created, right? So it's them that we should encourage and enable to be able to change the things that they want to change. I think decision intelligence could be something that can do that. AI couldn't. This is like AI 2.0, 10.0. So those are sort of my stories. Then 2019, I came here. I was offered an opportunity to build a business, and we had great partners, but they said, you have to move here. And I said, okay. So here I am. Thank you.
Would you like to, yeah. Would you like to take a moment to introduce your team here in case anybody wants to talk to them?
If they're still in here,
Yeah, I see a few.
introduce yourself.
Great. Thanks
And
very much
Trang,
for joining.
please.
Trang.
Yeah. She's like my right hand, my mom, my sister, like grandmother, everything. But yeah, that's interesting because that platform of Halt Prize was what sort of shifted the direction that she decided to take, quite frankly. And then she entered with me, and now she's working with me full time. So yeah, the team is amazing, and I couldn't do anything without them.
Everybody, please, come after, try to say hi to the team and take advantage of the networking time that we'll have after.
Yeah, please, I want you guys to engage with this conversation as well. And please feel free to talk to the team, to myself. And yeah, thank you. Thanks, Evan.
Thanks very much, Priya. So on that topic of personal stories, we'd like to dive in a little bit more now to our co-founder and CTO. Dr. Hareesh is, first of all, his background. So if I could introduce a little bit more. Dr. Hareesh comes to us after 25 years at Panasonic in the R&D department, where he created human digital twins for various ergonomic use cases. So when you model out the human body, things like joint articulation and the average height of people, that allows you to design a better physical world. Now he's taking all of that experience and helping us to develop digital decision twins so that we can model out these various use cases. And it's kind of like creating an avatar of the decision that you can go send out into various scenarios. In addition to this startup, he has another very interesting startup, and we'd like to tell a little bit more of the story of this. So Squash is actually Dr. Hareesh's company. And now I'm going to change the slides over and let's switch seats. You can come and tell us a little bit more about Squash. So for everybody on the Zoom call, please bear with us just for a moment. We're going to switch the slides over. It probably would be best, yeah.
Hello. Yeah. I'll try to make it very simple and short because there are a lot of, once I start talking, I might, if I got carried away, please stop me. Okay.
Sure.
So since today's topic is social impact, we thought we'll introduce this concept called this method innovation in wastewater treatment, which we started 5 years ago. As Evan mentioned, my background is I'm not a water specialist. I'm a computer scientist, and I've been in Japan for the past 27 years. And I did my PhD from Switzerland. We are specialized in AI, VR, and robotics. Like my work, my career started with the virtual reality field in 1997, and I've been making my own algorithms for topics whatever I covered. Those days there was no topic called AI. It was kind of artificial life or cellular automata, neural network backed propagation algorithm. Anyway, those were the days I had to create digital human, which you must have heard recently in metaverse and all. This is my PhD. I did it in early 2000, where I have to create I can create you in real time. And it's not only, it is for physical, evaluation of different ergonomic applications. So that means I can't just make a gaming module. It has to be validated with the actual scenario. And we did that. And Panasonic is now using it as a tool to, in the early design stage for making any of those products in Panasonic. They do that. They make this as a. The other one is the extension of that is for spatial solutions, not only the internal analysis, but external information like beam information, building information, all those things put together, created a basic version of that. All those things are with us, and we will be incorporating all those things. Some of these items for our decision intelligence in the future. And this is just an example to show, like, for example, when you design a kitchen, counter and sub-counter, imagine that a old woman carrying a 30 kilo from counter 1 to counter 2. A designer cannot visualize how is it possible or not. Those kind of early design stage and scenarios.
If we could take a quick moment there, I just want to point out that this is social impact, especially for the elderly or people who are maybe living life with a disability. Modeling out what that world is like for them and creating these scenarios where they can live a better life. Right. This is extremely impactful. So you've been doing social impact for a long time.
Yes. And Squash is born out of passion. It was nothing to do with my technology or base. There was a story behind that. Maybe during the discussion, I can tell how did it start, but I'll just briefly connect that later. But it is just born out of passion, and I'll just give you the glimpse of the scenarios like India. Just taking an example of India, you can see the water scarcity issue, water pollution issue. This is the normal way of all these canals and rivers in India. Not only India, like if you take Africa or in many places, people have this. And there are many solutions. There are many solutions available in the world, but still something is missing. We have SDG goals, we have solutions from different industries, but still, if you go to a normal house in India or a normal place in India or those places, the problem is still there. And that problem, so for example, one of these major culprit is contamination because of this used water. And the conventional wastewater treatment, the issues are like, most of them, for example, is not affordable for the common man. Like it is very complex structure. And even the minimum components that they are supposed to be removing, they won't remove it. So finally, sending up all the rivers and canals and everything, either heavy metals will be very high, DO will be, it's not eco-friendly at all, a lot of issues with that. Even the color, turbidity issues. So I and one of my friend in Japan, in Osaka, we were, there was a basic technology in Japan. We customized that technology. Our aim was first step was to create a special coagulant with specific combination of minerals that can convert wastewater to real water, clean water in real time. That's step one. It's not only transparent, it has to make sure that it deals with all the contaminations. It removes as much as possible, like BOD, COD, heavy metals, oil and grease. Most of these hotels, for example, in developing countries, the oil and grease, they just throw as it is to the drainage. So those were the things we were keeping as a base. And we could come up with a basic platform, which by customizing a little bit here and there, we can directly give it to like any of these domestic or industry or municipal wastewater. We did that last 4 years, 2018 to 2022, created the base, then started creating a simple concept. We just need one tank and a blower, that's all. So we scaled it from simple level to a mobile treatment unit to now we are doing this, urban challenge, urban drainage challenge is also in the progress. So effectiveness, simplicity, and also the sludge created also we could find out that it is biodegradable. Some of the item, not all. Industrial wastewater is difficult, but at least domestic wastewater can be biodegradable. I will just stop here with one video just to show you what is this scenario. So, so that is the coagulant we are putting in that. That is the basic scenario. I don't think it's messed. And it takes 30 seconds to 1 minute to remove all the suspended solids and most of these contaminations. Only that image I will put it in real-time video because there's a timer. So then you don't need a membrane filter. You just need a cloth to filter it out. It's already thickened, the sludge. Now this.
Can you guys see this image here? That was 30 seconds to sludge-filled wastewater, from sludge-filled wastewater to clean, purified water.
Then we scaled it up. I bought a truck, put the solar panel on top of that, created a small scenario, and it is now going on in different parts of India. Slowly, we just got recognition this year. We got award from Government of India and just initiated that process. And also this is in my, this is a small gray water system in my house. And I am also designing something which is, you don't need electricity, like using cycle, so that, people who can afford it for making that happen. Anyway, there was some real-time applications already happened. To connect towards decision intelligence, I'll have one more slide. So this is another topic of, effluence, industrial wastewater, also same scenario. It is a dye industry, jeans creation, dye wash. You see that it can in real time.
For the textile industry, when you're making clothing.
Right.
Of course, the dye would just go into the wastewater, rivers, and whatever.
Right. And this is paint industry. Same scenario. Okay. And last point is, so recently, this is the topic, is a challenge which most of this pollution happens because all the people, the drainage water, when it goes to the river, this is a scenario. And I just took one spot in India, the place I want to do a challenge. And this is the area where almost 2 decades of, garbage place was there in nearby. During monsoon or any time, this kind of black water start flowing. And all the canal in that area is like this for 10 years. They still could not solve it. And I just tried one step, the same water. I'll just show you the result here. It was happening. We are able to make it clear. First step was make it clear, transparent. So this happened a couple of months ago. It is a government project. Now, as a next step, we analyzed that, the contaminations, it is coming within the norms. Like this is a before-after scenario. Now, this is a proof of concept we are planning to set up there. Like, since this is a real-time treatment, any water which goes to the river or canal, the drainage, before it goes to the river or canal, we allow them to just pass through our system once. So that within 6 months, my dream is to make sure that most of these Indian rivers or canals are clear and clean at least. That's it. So,
it is an incredible personal mission that you're on there, and a great social impact story. Right. And so obviously there are multiple logistical issues to overcome, and it could potentially be daunting because you don't know what's going to be most impactful. Should you solve this problem or this problem? So I think to tie it in, this is where decision intelligence helps to prioritize the most meaningful actions. Maybe you could tell us a little bit about that part, and then we'll open it up for Q&A. Let's have a discussion.
Right. So this topic here, though it looks very simple, and so it is not that, it's so complicated. And even this scenario itself, like we don't have a control over the flow rate. Anytime it may flood, anything may happen. So there are a lot of risk factors, there are a lot of issues to be solved. So what we are planning is through Kimaru, for example, like creating a digital twin of that area. We have already now connection from satellite. We have almost 50 years of information already available in the net, all the static data, even dynamic data is also available. Those information, we can have a digital version of the area where we are, focusing with all the technologies are available, all the IoT sensors and feedback system available. It is not complicated, but as Evan mentioned, we have to properly design that, what is that items, we have to quantify that. There should be a metric form, what is the action outcome we have to take. There could be different levels, like as I wrote here, like strategic decisions or tactical decisions or even operational decisions at the day-to-day basis. So there are many levels of decisions. We might need different levels of DI platform for that.
Right. Okay, thanks very much. So I'm sure you guys have lots of questions. Let's open it up. Does anybody want to raise their hand or come up here? Yes, Dustin. A little louder, Dustin. Can you take us through like an example run? So for maybe the squash use case? Okay. Well, it basically works like this. You work with the decision builder to determine your outcome, and that's based on your North Star metric, so a quantifiable metric, something that you can put a numerical value to. Then you work backwards from that, and you map out the actions that you can take, and then you think, are there any actions upstream from that might influence them? Very often there are. And so the actions upstream become the levers that you can pull. The downstream intermediate actions become causal chains, and you map external factors like flooding in this case that you can't control. Once you've built that model, it gives the humans a visual interface within which to work, but it also creates the guardrails, the training environment for machine learning algorithms. And then you can pick up data sources just at the nodes connected to the action levers that you pull, that you've determined are within your control that will affect that desired outcome, critical KPI. Then you can, then we will, our engineers, build the AI prediction and recommendation models that are visualized in that front-end decision builder. And they tell you, would it be more meaningful to take this action or this action? And by how much? So the users can tweak the parameters once the decision model is built and model out, would it be more impactful, let's see, in this particular squash use case, to put the water cleansing unit at this point in the river where the flow rate is relatively high, or at this point farther downstream where the flow rate might be a little bit lower, but there are more contaminants aggregated, and so it's more meaningful to filter them out there. The models will tell us which is likely, statistically significant, to be more likely to achieve the desired outcome. Does that help visualize it? Okay, great question. Yes? Yeah, absolutely. Look at our website for an example of that. Our demo video on the website specifically models SaaS revenue. What can you do to increase your projected revenue, sales or marketing? That's the use case in that video there. But yeah, certainly, Daniel. Hmm. Mm. Decision would be better because having a better relationship with that person who kind of influence the relationship. Right. There are basically two aspects there. One is filtering out human bias, which the act of building a decision model does intrinsically because it's a team exercise and it highlights biases like that. It brings it to the forefront. And then the second part is the team can try to quantify whether that actually is a benefit or not. So you would, in the case of that relationship, put something like time to decision as the metric and say, would this person be able to leverage that relationship to get us to our desired outcome faster? And is that a good thing? Would that, let's say, trading of favors or cashing in on that relationship give us a relationship debt in the cost center of that equation? The decision modeling exercise is like digital nemawashi. It's getting all of your stakeholders aligned. And that initial process really activates all your team members and gets everybody on the same page. You can do that in a whiteboard, and it's extremely valuable. Right. Right. Put the guardrails around it and determine what is meaningful, what's within your control, what should maybe go into a different decision model. It's a very good exercise in critical thinking and essentially design thinking. We have time for one more. Okay. Yes?
The squash solution, is it a generic one or does it need to be customized for a specific user? And what do people do with the sludge? How it's buried again?
Right. Thank you.
Maybe use the mic, Dr. Hareesh.
Thank you, sir. As of now, we, as you see here, this is a startup company, and I started out of passion. It's like initiated, as a passion, but now it is slowly getting into visibility. So there are two aspects I would like to explain. One is how it is, how the way we created this, the concept itself. We segregated that water itself into 6 categories. 6 categories: black water, gray water, clear water, clean water, safe water, drinking water. Different 6 levels. And of course, I cannot approach all these things together. So I want to go step by step. So my first step was to make it up to clean water level, transparent. All the turbidity is removed so that sunlight passes through the water. All the ecosystem could be, like sunlight and everything beneficial. Once we did that, it's a total, suspended solids are removed, but that is not enough. We still have heavy metals, oil and grease, a lot of things are there. Then once we get into that stage, it is clean water. Still, it is not drinkable because we don't touch bacteria. The pathogen is difficult. That is a different topic. But we can boil it and drink it. That's a different topic. In Bangladesh and Australia, even Africa, people start doing that. Now, up to clean level, we have achieved now as a generic platform. Then now, since we give it for the difference between an industrial wastewater and a domestic wastewater is that only thing is we have to add extra powder to coagulate more. I mean, the heavy metals also.
We'll
The-
probably have to save the rest for the networking, where you can explain it in a bit more
Oh,
detail.
okay,
'cause
so I'll make
we're
it very
at
simple
time.
that for sludge, for the domestic wastewater, we can use it as a fertilizer. For industry, we have to collaborate with sludge people to extract those heavy metals separately. To is another business. Maybe we can talk that in detail.
Yeah, you can chat one-on-one after. Okay, we have to wrap up the session. We only had an hour. Feels like we could talk for 3. But I want to end on a note of optimism. We started by talking about the SDG initiatives and how we're behind. But these planetary issues are not insurmountable. If we break them down into the individual decisions we have to make, if we apply this methodology, we can overcome great challenges. So for all the young people in the room, don't be discouraged. We will still save our planet. You will still have a great career. We just have to leverage the power of human experience and human judgment and our AI assistants. Thanks, everybody.